Okay, so today we're going to look at section 2.1, which is simplifying algebraic expressions. Okay, we're going to look at identifying terms, like terms, unlike terms. Okay, talk about the distributive property, combining like terms. I apologize for the sniffles. I kind of got a little bit of cold. Okay, so a term is just a number or the product of a number and variables raised to powers. So for instance, when you're talking about terms, 5x would be a term. Okay, it's the product of a number and a variable. Okay, but it doesn't have to have a number. It could, a variable. It could just be a number. Okay, it doesn't necessarily have to have a number. Sometimes we just have variables. Could be multiple variables. Could have different exponents. Okay, there's lots of things that are going to be a terms. The big part here is that they're all multiplied together. Okay, what you don't see, and you don't have to write this down in your notes, but just to kind of show you, if I had like 2x plus 3y, okay, well, that plus is what separates my two terms. Okay, so this 2x makes one term because these are all multiplied 2 times x. 3y would be another term. Okay, that's a positive 3y. So there's two terms up there, a 3x and a 2x and a 3y. Keep in mind these things can be negative as well. Okay, no matter what it looks like, it can be negative, and that negative would just go with the term. Okay, but if it was a minus in between, so again, going back to that idea, if it's 2x squared minus y, well, now I'm splitting it up. That plus and minus splits the two terms, so I've got 2x squared and negative y. That would be my two terms. Okay, so that's how we identify a term. Okay, with the term, there's a part of it that we pay specific attention to, which is the numerical coefficient. Okay, the numerical coefficient of a term is the numerical factor. Fancy way of saying it's the number out in front. That's really all it is. It's the number out in front. I would make a note to myself, every term has exactly one numerical coefficient. Okay, only one. Coefficient. Okay, so only one. Okay, you can't have more than one numerical coefficient per term, and you can't have, there's no such thing as a term without one. Okay, we'll talk about what it is when there is no number here in just a second. So let's start with an easier one first, though. So if I'm talking about a term, so let's say 5x is my term. The numerical coefficient is just the number that goes with the variable. So here my numerical coefficient is just 5. Okay, so the same thing would happen if I have something like this. I said no such thing as something without a numerical coefficient. So if there is no number listed, then that number is always 1, because I technically have one ABC. Okay, because 1 times anything is still itself, right? So I can have a numerical coefficient of 1. Same thing would be true if I had a negative. Okay, negative x squared y, so that would be a negative 1. Okay, so if there's no number listed, we always consider it to be 1. If it's positive 1, negative, it's negative 1. Okay, other than that, it's just kind of that number out front. If there's a negative that goes with it, the negative goes with the number. Now, the one that throws people off the most is if I have an x, a variable, over a number. Okay, here my coefficient is going to be 1/2. Okay, because there's technically a 1 in front of x and there's a 2 on bottom. Well, that 2 on bottom in the denominator matters. Okay, so that's a coefficient of 1/2. Keep in mind that x over 2 is the exact same thing as saying 1/2 x. Okay, if I were to multiply these back together, I would get x over 2. So just one more to kind of solidify that. If I had 2x over 3, for instance, then my coefficient would be 2/3. Okay, so that's what the leading coefficient is, okay, or the numerical, I'm sorry, not the leading. The numerical coefficient is just the number that goes with the variables. Okay, so now let's talk about the variables. Terms with these same variables raised to exactly the same powers, and we'll talk about that in a minute, are called like terms. Okay, terms that aren't like terms are called unlike terms. Okay, now typically people just say that they're not like terms, but unlike terms is what they're actually called. So let's take a look at some examples. So for instance, if I have 5x, Okay, and I'm looking for like terms. Like terms is going to be anything with a variable of x raised to the first power only. So 2x, negative 3x, 0.5x, x over 2. All of those would work because they all have an x raised to the first power. Okay, unlike terms, x raised to any other power, okay, squared, cubed, anything like that, none of those are going to work. Okay, obviously if it's not even an x, it's not a like term. They have to have the exact same variable, okay, and they have to also have just that variable. So like x, y would not work because this is just an x, so it only matches up with other ones that are just x's. You gotta imagine that x has a very specific value to it, so you can't just call everything, if it's x squared, well that's a bigger value than x, so I can't say that, you know, if I add another x squared to an x that they're going to be the same thing, because they won't. Okay, so those would be unlike terms. There's an infinite number of unlike terms that I can put there, but these are just some examples. Okay, so same thing here. So if I'm given negative 3x squared y, when I'm talking about like terms, all I care about is those variables right there, x squared y. So all of my like terms must have x squared y. Okay, so 2x squared y. Okay, just x squared y. Again, any number that I want to put there, 7,000 x squared y's would still work as long as it's x squared y, x squared y, x squared y. Okay? Unlike terms, every one of those is an unlike term, right? Because none of these have x squared y, so those would all work. But the ones I want you to kind of pay attention to that confuse people, okay? X, y. Exponents have to be the same. Yes, they both have an xy in them, but this is an x squared y. This is an xy. Okay, there's no exponent of 2. For that matter, if I have 2xy squared. Okay, again, not the same, because here my square is on my x, here my square is on my y. It has to match up exactly. It needs to be x squared y. X to the first, y squared. That's not the same. Another one I want you to caution you about. Okay, and this is the one that fools people the most, because now I've got an x squared y, but that x squared y is in the denominator. Okay, an x squared y in the bottom is not the same as an x squared y in the top. Okay, so if my x squared y is down in the denominator, unless my original term was x squared y in the denominator, then they're not like terms. Okay, so one more time. This one's just got more variables, ab squared c cubed, same sort of thing. This is a decimal, it doesn't matter. I can have a decimal. 0.2ab squared c cubed. That would be a like term, but it doesn't have to be a decimal. It could be 100ab squared c cubed, as long as it's got that ab squared c cubed. Okay, hopefully by now we're kind of getting that idea in there. So unlike terms, abc would not work. Okay, ab squared c does not work. All of them have to match. It's not okay if only some of them match. Okay, every one of them has to have the exact same power, the same variable with the same exponents. You know, obviously we can't just switch variables. Okay, you can't say x squared y or xy squared z cubed. Okay, those are different variables, which means it's not like terms. All right. So this is another one that kind of throws people off here. Are 2x squared y and 3yx squared like terms? Okay, well if you're thinking yes, then you're thinking correctly. They are like terms. If you were thinking no, I understand a lot of people do, but you have to look at it. Okay, this is an x squared y and a yx squared. I've got an x to the second power, x to the second power, y to the first power, y to the first power. Okay, all of my variables are there, both have x and y, both have the powers the same on each one. You have to remember that 2 times 3 is the exact same thing as 3 times 2, which means that I can rearrange multiplication, because that's all this is, 3 times y times x squared. So 3yx squared is the same thing as saying 3x squared y. Okay? 2 times 3 times 3 is the same as 3 times 2, 3 times 3 times 2. Okay, I can flip the order of them, and I'm still going to get the exact same answers. So be very careful there. A little helpful hint for you is that if you write your variables in alphabetical order, and I'm going to write this out for you so you can put it on your notes. Okay, so if you write variables in alphabetical order, then it's going to make your life a lot easier, because then when you go to combine like terms, then your variables, then you're going to match up a lot easier. If everything's always in alphabetical order, then it makes it a lot easier to match these things up so you don't accidentally miss things like that 3yx squared and 3x squared y are the same thing. Okay, so write your variables in alphabetical order. It will make your life easier, especially when we start doing very large polynomials and we multiply them. That's going to come in very handy. Alright, so simplifying algebraic expressions. Simplifying the sum or difference of like terms is called combining like terms. Okay, so combining like terms, very fancy way of just saying that well, combining like terms isn't really a fancy word. Okay, we've been talking about combining like terms since probably 7th, 8th grade, Algebra 1, definitely. Okay, simplifying the sum or difference of like terms. So if they give me something like this and they tell me to simplify, they just want me to combine those like terms. So 3x plus 2x is 5x. Okay? Realistically, what's happening here is I've got 3 x's. I'm adding 2 more x's. So 3 plus 2 x's is going to be 5x. Okay, this is not how I'm typically going to write this, but realistically this is what's happening. We're adding the numerical coefficients, keeping the variable. Okay, 3 x's, add 2 more x's, I now have 5 x's. Don't change the variable at all, not when we're adding and subtracting. Okay, on that second part there, okay, so this is just some examples. So 10y squared plus y squared. Remember that the coefficient here is 1 when it's not written, so 10y's plus 1 more y is now 11y squared. Okay, variable doesn't change, it's y squareds before, it's y squareds at the end. 8x squared plus 2x minus 3x. First of all, we have to identify which are like terms, because I've got more than one type of term here. Here I've got 8x squared, so I've got an x squared. I also have a positive 2x and a negative 3x. Okay, so I have 2 of them that have x to the first power, one with an x to the second power. This has nothing to combine with, so we're just going to write it down. Okay, please remember to write it down. So many people lose points on this test because they're so focused on combining like terms that they totally forget to write down the stuff that was not combined in the first place. But it's still part of my expression. So 8x squared, and now I've got positive 2 and negative 3. So all you have to do is, what's 2 minus 3? Okay, well 2 minus 3 is negative 1x. Okay, negative 1x. Now I didn't write the 1 because we don't have to write a 1 in front of x. The fact that there's an x there implies that there's one of them. Okay, so 8x squared minus x. If you do put a 1 there, it is not incorrect. You're not going to lose points. It's fine. It's just not mathematically proper, I suppose is the right way to say that. Okay, it should say 8x squared minus x. So this would be my final answer there. Okay, when I'm simplifying by combining like terms. So same thing here. Okay, just match up all of your like terms. So I've got negative 5a, positive a. I've got negative 3 and positive 2. Notice I use little lines. That's just for me. That's my way of organizing. You can box or circle. You don't have to do anything, but we do polynomials later on where they get very, very large. So it is nice to have some kind of method to make sure that you don't leave any numbers out. I see a lot of people that combine like terms and they accidentally forget the negative 3 in the middle or something like that. So if I kind of go through and I underline them, then it makes it easier for me to make sure I don't leave things out. So I've got negative 5a and positive a, which makes negative 4a. Okay, that's just combining negative 5 plus 1 is negative 4, and negative 3 plus 2 is negative 1. Okay, again, the a's don't disappear. We still have the a there. Because we had negative 5 a's, we added 1 to it, we now have negative 4 a's. Okay, so negative 1/2 b plus b. Okay, you can kind of do this mentally. If I'm taking half away from a whole, then I should end up with a half. But if you don't, okay, you would look at the fractions, and we did this in the first unit. Negative 1/2 plus 1. We're going to put that over 1, get my common denominator. So I get negative 1/2 plus 2 over 2. Which is 1, negative 1 plus 2 is 1 over 2. So I get positive 1/2 b. Okay, positive 1/2 b. You do need to still be able to work with those fractions. It's very important. Okay, so use the distributive property to simplify. Now it's important that you note that Distributive property can be used to remove parentheses while simplifying expressions. Okay? I noticed in Unit 1 that a lot of students are not removing parentheses when they distribute. Okay? When you distribute, the parentheses go away. That's kind of the point of it. So make sure that after you distribute, that you keep the parentheses. So for instance, this means 5 times everything inside the parentheses, 5 times the sum of x and 2. Okay? So when I multiply it, okay, I don't want just 5 times x. If they wanted 5 times x, they would just write 5x. But they want 5 times this whole thing, so I must multiply that 5 into each one of the internal terms. So again, the terms are split by the plus sign, so it's 5 times x. And I put a plus between it. Okay, I'm going to put a plus between each one of them, and this is 5 times 2. So that gives me 5x plus 10. Okay, so 5x plus 10, that's what that looks like. Be very careful, this is very different than this term. And I know this isn't really in your notes. Oops, sorry. Okay, I know this isn't really in your notes, but I wanted you to notice the difference here. This is 5 times x plus 2. This is 5 minus x plus 2. If I were going to do this, the only thing that would distribute is that negative sign. Okay, so here I would get 5 minus x minus 2. Okay, that's a little bit different than what I got here. Okay, because this would be negative x plus 3 versus 5x plus 10. Very big difference in value. Okay, so be very, very careful. If it is a negative touching the parenthesis signs or a plus sign, that means I should be adding or subtracting, so that is what distributes. If it is a number touching the parentheses, then I should be distributing that number. So for instance here, I got a minus sign out front, so I'm going to distribute that minus sign. Okay, distributing a minus is the same thing as multiplying by a negative 1, because that's all that's really there is a negative 1. So negative 1 times x is negative x. Negative 1 times y is negative y. Negative 1 times negative 2, that negative and negative makes positive 2z. And negative 1 times positive 6 makes a negative 6. And if you look, all that really happened is everything inside here just changed signs. Okay, so I had positive x, positive y, negative 2z, positive 6, and now it's negative x, negative y, positive 2z, negative 6. Everything just switched signs. Alright, so last one here for those, okay, you just have to be careful with what you're distributing here. Because this negative 2, first of all, yes, the negative does go with it, okay, the negative 2 applies to both of those. Okay, but it only applies to those because that's the only thing that it's touching. And this negative here applies to both of those. So I would get negative 2x minus 2. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. Okay, so I've distributed both sets. Notice I did not write parentheses. My point was to get rid of my set of parentheses. So now that I'm here, it's all addition and subtraction. There is no more multiplication. So now I'm going to combine like terms. Negative 2x and negative x makes negative 3x. And then I have negative 2 and positive 2. Well, those are additive inverses of each other, so they equal 0. So my final answer there is just negative 3x. Okay, in that very last section, we just need to be able to write phrases into algebraic expressions. Okay, and the biggest part of this is just knowing which order to put it in. So for instance, first of all, if they say write an expression or a mathematical statement, you need to use the numbers as well. A lot of people on the first test just put symbols and no numbers. Okay, 2 subtracted from negative 1. Well, if I want to take something away from something, I have to have that something first. Okay, so if I want to take 2 away from negative 1, I have to start with negative 1 and then take 2 from it. Okay, this would be 2 subtracted from negative 1. Same thing here, 3 less than 4. We did this in the first unit. But if I want to be 3 less than 4, well, I have to start with 4 to be less than it. So we're going to take 4. 3 less than 4 would be 4 minus 3. 5 increased by 7 is a pretty easy one. If I want to increase, I add. Okay, so here, subtract 4x minus 2 from 2x minus 3. So there's again that from. So that means I must start with 2x minus 3, They put it in a group, so I'm putting it in a group. And I will subtract 4x minus 2 from it. Now here's the super important part. Without this set of parentheses, the answer is incorrect. I can lose this set of parentheses because it's a positive out in front. Okay? But this set of parentheses, if they want me to subtract this whole thing, I must put it in parentheses. Otherwise, the only thing I would subtract is the 4x. If I want to subtract the whole thing, the parentheses says that I'm going to distribute that negative so that I'm subtracting both terms, not just the first one. So that set of parentheses is an absolute must. Without it, it's the wrong answer. So be careful there. All right, so the difference of a number and 4, comma, divided by 7. I made a point about the comma, because remember in the last unit, that ends that statement. So the difference of a number and 4. Difference of a number and 4. Okay? Divided by 7. So that was the end of that thought. So when they say divided by 7, they mean the whole thing divided by 7. Not just the 4. Okay, if they wanted it to just be the 4, they wouldn't have put a comma there. They would say the difference of a number and 4 divided by 7 without the comma. They wanted the difference of a number and 4 divided by 7. So you have to be very careful there. Okay, and watch the way you write it, because if your handwriting's sloppy and it looks like x minus 4/7, and I'm going to assume it's x minus 4/7, you need to make sure that you are very clear, or you use parentheses around that top set so that I know that you're trying to divide the entire x minus 4 by 7. All right, 5 added to 3 times the sum of a number and 1. I'd say it's the last one, but it's really not, because I'm going to add one more to it. 5 added to 3 times the sum of a number and 4. Okay, and the one I want you to add to it, and we're going to talk about them at the same time, is 5 added to the sum of 3 times a number and 1. Okay? And you're probably thinking that's the same thing, but read it a little closely. 5 added to 3 times the sum, 5 added to the sum of 3 times a number. Okay? And I added that one because I want you to look at the comparison between the two. Okay? 5 added to 3 times the sum. Okay? So you got to ask yourself, what am I multiplying? 3 times what? It's 3 times the sum. Okay? Well, what is the sum? A number and 1. Okay? So when I write that, 3 times the sum of a number and 1. Okay? So this is the sum of a number and 1. This is 3 times the sum of a number and 1. And then they wanted 5 added to that. Okay, if you did plus 5 first, it would be okay. Remember, plus 5, when you're doing addition, addition can go either way. Okay, the addition can go in the front or the back. 2 plus 3 is the same as 3 plus 2. Just make sure you don't do it with subtraction, because 2 minus 3 is not the same as 3 minus 2. So be very careful there. Okay, so this would be F. 3 times the sum of a number and 1, and 5 added to that. Now on G, the one that I added, 5 added to the sum of 3 times a number and 1. Okay, so here I had 3 times the sum. Here I've got 3 times a number. Very big difference. 3 times the sum means I put parentheses. 3 times a number, well, we know how to do 3 times a number. We did that in the first unit. Okay, 3 times a number and 1. So they want the sum of 3 times a number and 1, and then 5 added to that. Okay, technically I would put parentheses there, but you don't really need them because it's all addition, right? Addition doesn't matter. I can change the order of addition. So that would be the difference there. This is 3 times the sum of a number and 1. This is the sum of 3 times a number and 1. So be very careful there. You will see both. Make sure you understand the language. And that should be able to get you through the first homework assignment for 2.1. Good luck with that.